Today, we present MUZX, a visualization-based system that has the goal to help the user search and explore a large multivariate bipartite graph of artists and songs. This project was developed in the context of a research work conducted in tight collaboration with Bibliothèque et Archives nationales du Québec, which is the National Library and Archives Agency of the Quebec government. The institution had a data set of around 24,000 songs and 19,000 artists initially stocked in a relational database. This data set is composed of adaptations of songs as well as metadata about the agents who composed or interpreted the musical piece, the language of the interpretation, the date of creation, and various other historical information that would be useful for the user. The database aimed to offer a serious and as exhaustive as possible look on the phenomenon of musical adaptations, which greatly affected the francophone space mainly between the 40s and the 80s. The extensive work behind the database and the multiplicity of access points make it possible to search for ad hoc information as well as to carry an in-depth analysis in the context of an exploratory search. Here you can see the client-server architecture of MUZX. The RDF graph was built from the relational database, so we had to make various choices in regards to the data model. Authority records for artists and songs being the two main entities present in the original dataset, the data model mainly focuses on these two concepts. There are different relationships between artists and songs, for example, composition, authorship, and performance, and relationships between songs, that is, between the parent song and the adapted song. Finally, there are relationships between the authorities themselves, for example, between members of a group or temporary partnerships. We also encoded information with literal properties or with external links, for example, to the DBpedia pages for countries, languages, and artists. Since the dataset was built in a library context, we opted to model the data according to the RDA registry. RDA, Resource Description and Access, is a standard used in cataloging, specifying guidelines and rules on the description of bibliographic data. RDA registry consists of vocabularies representing RDA elements, entities, and terminologies in RDF. We also had to create a few new properties to represent a number of relationships since these were absent from the RDF representation of RDA. The dataset in RDF is stocked in a GraphDB triple store, and data is queried via a Sparkle endpoint with Sparkle queries. The system targets several tasks that allow us to identify a set of 11 target questions that the users should be able to answer when exploring the dataset. These questions were gathered from multiple sources: discussions, interviews, and brainstorms with the National Library's collaborators, and a literature review on bipartite graph-based visualization systems. As you can see, question 1 to 3 seek to explore the whole data set from an artist's perspective. Question 4 seeks to explore the adaptation flow by aggregating adaptations along the main country from which the involved artists are operating. Question 5 and 6 seek to understand the whole and sometimes unexpected genealogy of a song in terms of adaptations and their lyrics language. Finally, questions 7 to question 11 are transverse and artist-centered. They seek to characterize how a specific artist's body of songs is structured in terms of adaptations. In order to attain these targeted questions, the exploration interface is based on 4 main exploration views that I will now demonstrate to you. The tool has been developed with the D3.js and Vue.js libraries, so is entirely in JavaScript. In that dataset, an artist has 3 different possible roles: songwriter, composer, or singer. Each role can be held by multiple artists. For example, the song Please Please Me was written and composed by both Lennon and McCartney in '62 and was sung by the Beatles. Based on this characteristic, the dataset can be first structured into a bipartite graph with artist nodes on one side and song nodes on the other. This is the artist global view. This view allows the user to do an overall exploration of the whole set of artists and to answer question 1 to question 3 presented earlier. It can be used as an entry point into the system since it does not need any user input. This characteristic is very interesting in the context of exploratory research because sometimes the information need is not completely defined or identified. Using this view, I'm able to identify which artists are the most popular in terms of their songs being adapted by others. Each disc represents an artist, and coding is number of songs as the disc surface. The x-axis refers to the percentage of his songs that have been adapted by other artists, and the y-axis refers to the percentage of his songs that are adaptations. I can search for a specific artist and it shows me where in the view this artist is situated. I can also filter the results by country and navigate into these results. It's also possible to filter by the birth year of artists, and it shows us that most of the artists in the database were born between the 1920 and 1940 and 1940 and 1960. Once an artist is chosen, for example, I'm going to go back to my Paul Anka example. We can click on the bubble and access the relationship exploration view for this artist. This view allows the user to dive into an artist's body of songs and relations. It targets the question 7 to question 11. Given a chosen artist, so here we chose Paul Anka, this view enables the exploration of the subset of all the songs in which this artist is directly involved. We call them the level 0 songs. The level -1 songs refer to the potential direct parent songs in terms of musical adaptations, and the level +1 songs refer to the potential direct children's songs. So in other words, level 0 songs represent the body of songs of Paul Anka. Level -1 songs are the songs at the origin of an adaptation in which Paul Anka is involved, and level +1 songs are adaptations from songs in which Paul Anka is involved. So this is the main top panel. You can see 3 timelines gathering the songs from each of these levels, allowing an exploration of this inspiration aspect over the temporal dimension. In the bottom panel, for each level, we represent all the other artists involved, along with their roles. The small bar charts represent the relative number of implications. As you can see, Paul Anka was mainly a singer, but he also wrote and composed songs. As you can see, when I hover with my mouse, it shows me all the different songs and the relations with the different songs from level -1 and level 1. For example, the song My Way we see that it comes from another song, Comme d'habitude, and it was adapted in different songs. Sorry. If I click, as I just did, on the song My Way, I'm going to have more details about this particular song. So I see that it was, the date of creation is 1968, and it was written by Anka, and there were many interprets of that song. This is the song genealogy view. Another characteristic of the dataset is the fact that song lyrics can also be adapted in another language, but also in another lyrical version. This made it possible for us to structure the song nodes into three structures based on the adaptation edges. The average number of songs per tree is 3.4 in the dataset, and the maximum depth of an adaptation tree is 4. So this view, the song genealogy view, it targets the questions 5 and 6. When a user clicks on a song, as we just did, we can visualize the full tree genealogy of a song along with the language of the lyrics of the song. As you can see in the song genealogy view, the song Comme d'habitude was written by Claude François. It is at the origin of the song My Way in the United States, but also at other adaptations in the UK, Italy, Portugal, Denmark, and France. Not surprisingly, the song interpreted by Frank Sinatra and others gained popularity in the beginning of the 70s, and the song was adapted more than 10 times in different countries of the world, as you can see here. Now I'm going to go back to the other view to show you the country pairwise flow views. These views target question 4. It allows the user to visualize the international influence and inspiration of an artist in terms of adaptation flows between countries. In this view, we can see the same songs as in the relationship exploration view, but they are reorganized along the directional adaptation flows between the countries associated with the artists implicated in the song. This chord diagram, the inspiration one, shows from which countries are the songs Anka adapted. The other one, the influence one, shows to which countries Anka's songs were adapted. The chord diagram presents a radial design where a chord width encodes the number of songs adapted from a country to another. So the user can filter the songs according to the time period or even according to the role, author, or interpret, because Anka was never a composer of any song in the database. If I click on one chord, for example, this one, I can see the 39 adaptations that are from Canada to France. So all the songs of Anka that were adapted in France. So that's it for the demonstration. You can explore the tool yourself. An online implementation is available at MUZX.widify.io. Thank you for your attention, and we would be happy to answer any questions you have. Thank you.